Good day, everybody. We have an interesting problem dealing with the first three terms of a geometric series. This is different than what you've probably seen because it involves irrational common ratio. Y'all, and I'm just writing down the terms of a sub r, and then a sub r squared. A times r squared, excuse me. Okay. Now notice that this thing called r is the common ratio, because notice that if we take AR and divide it by A, we get R. But notice that's the very same thing as if we take the next term, the third term, and take its quotient with its predecessor. So we have AR squared over AR, and that's literally why it's called the common ratio. The next term would be AR cubed with a similar set of circumstances, all right? So you see, this is called, R is the common ratio because it's the ratio of successive terms, all right? Now, we're taking R to be a positive number here. It's kind of tacitly implied here. And we know the first three terms of a geometric series, we have a constant value, an unknown term, which we're trying to find, and then the third term. Okay, and y'all, by the way, make sure you stay out of bars with sparklers and a lot of alcohol. Now we're supposed to determine the value of x here, and based on what I just said up here, this is what happens. Okay, I'm not going to say a hell of a lot about this. It's a bunch of just grunty algebra, you know. But you can see what I did. This statement right here is a consequence of just this statement up here. Okay. All right. And then when you isolate everything, and some people call it cross multiplying, I guess, but you get this statement right here, and we are trying to find x, right? Now, something that I don't know, that's maybe, let me say one more thing. Notice if you have x, you have square root of x. Okay. Now what? The fourth root of x, and so on. Notice another way of saying the fourth root of x would just be to say the square root of the square root of x. Now, I think there's quite a few people that don't like this notation. They'd rather just call this x to the 1/4. But I did it this way, where I nest the radicals, or it's, and then the eighth root of x is, of course, the square root of x to the, like this, okay? So that's what I'm doing. I'm not dealing with rational exponents in this video. A lot of people use that as a crutch. I like using the radical. I like it. It works just fine. It's operational. But this to me is more, I just like the look of it. It's a matter of taste, I guess, okay? But we'll be using that idea as we try to solve this. Now, right here, we have the fourth root of 117, the fourth root of 13, and you can combine those together. That's a standard property of radicals. All right. Now, to bring this inside, you actually have to raise it to the fourth power. Okay. To bring this, if this was a square root, to bring this object inside, you would have to square it. But since it's a fourth power, we actually have to raise the square root of 39 to the fourth power. But if you write that down, square root of 39, square root of 39 times square root of 39 times square root of 39, you get 39 squared. And of course, you get 3 to the fourth here. Okay? Now, the rest of this is basically what I just told you as far as what I'm doing right here. We got a nice, this part here, folks, did require a little bit of work. To notice that there's 3 3s. This is 9 times 13. And this has a 9, let's see, this has a 9 in it also. So that's 3 to the fourth, and also you have 4 copies of 13. And that makes things a lot simpler to do the prime factorization a little more, just simplify the prime factorization in this fashion. Okay, now that's very nice, because we get this statement here, the 3 to the 4th terms cancel. All right. But notice, if you must, you can write this as, some of you may prefer just to say 13 to the 4 over 8. You know, I don't have any, you know, it's totally style, you know. And that's equal to 13 to the 1/2, right? But some people just see this. I like to just look at this and say the answer is the square root of 13. Okay, to me it's a visual, like, this is what this means to me. It means this, okay? But a lot of people that like rational exponents would prefer this, which of course is the same as that. Okay, so we have determined that x is equal to the square root of 13. And again, I like this problem because 99% of these arithmetic progression problems involve really nice integers or rational number common differences, you know, like you're used to seeing the real standard 2, 6, 10, where it's very clear. Or no, wait, that's not it. Sorry. Oh, yeah, well, okay, we can do this. Multiply by 3, 18. Okay. So the common ratio on this one, it's very easy to see, but you change it to an irrational number, and it's a little bit more work. You know, quite a bit. It's substantially more work, even though it's the same exact principle. Okay. So anyway, let's see, what do we get? We got the square root of 13. So that's our answer, square root 13. And also notice, you could have said find the common ratio. Well, each one of these expressions involves the common ratio, sort of. It is the common ratio, but you don't know what x is. So, but you could now that you know x, you could actually compute the common ratio. So that is to note, we found the answer to this without actually explicitly finding the common ratio. Okay. So anyway, that's another problem. It's just you could finish it here, but I'm not going to mess with it. So we are done. Sorry, man. Gotta go. Okay.